So this is part 2 of our videos for section 7.2, confidence intervals for a single mean. So we had left off with trying to find a 99% confidence interval for our parameter of the number of hours of sleep, the average number of hours of sleep ARC students get. So we're changing the level of confidence to 99%, so that means that alpha is going to be 1 minus 0.99, right? Convert the 99% to decimal to find alpha. So alpha is 1 minus that, so that gives me 0.01. So what does that mean? So then alpha over 2 is, so divide 0.01 by 2, which gives us 0.005. So this is then our alpha over 2. So when we go to our table, so over here we're going to go to one tail 0.005. So that's the first one. Or you can go to two tails and do 0.01, which notice is still the first one. So we're still looking at the same value. And our sample size is 39, so degrees of freedom are n minus 1, so 39 minus 1 is 38, so it will be 2.712 will be our new critical value, so 2.712. So our t of alpha over 2 is 2.712. So that is our new critical value. So everything else about the confidence interval will be the same as before, but now we're changing the critical value to 2.712. So when we had over here for the error, we had our t sub alpha over 2, right? Notice this will be the same, but now instead of 2.024, we're going to put the 2.712 and find a new error. So let's do that. So therefore our error is the critical value 2.712 times the standard deviation over the square root of n, which was 1.521, and then put that in our calculators and that will give us the new error, right? And then so that means that our 99% confidence interval then will be our x bar minus the error that we find. This is going to be the lower limit of our mu, and then the upper limit will be our x bar plus the error. So for our error I got 0.6605. So rounding to 3 decimal places, that will be 0.661. So to 3 decimal places, because that's what our x bar, our average, was rounded to. And our average was 7.372. Is that what that was? Let's scroll back up. 7.372, yes. So that was our x bar, and then minus the error, so 0.661, and then mu less than, now our x bar again, 7.372 plus the error. And so this gives me the lower limit and then the upper limit. So compute those and we can see what our new confidence interval is with 99% confidence. So for the upper limit I got 8.033, and for the lower limit 7.372 minus 0.661 I got 6.711. And so what happened? So with the higher confidence, so 99% confidence interval, notice that my interval got wider. So it went lower on the lower limit and it went higher on the upper limit. And now notice that this goes slightly above 8. So now our parameter could be 8, could be the recommended number of hours of sleep, because now this saying with 99% confidence the population parameter, so the average number of hours slept by RC students on a typical night, is between 6.7 hours and 8.03 hours. So now 8 is part of the interval, whereas before, right, with 95% confidence we can say that ARC students are sleeping less than the recommended amount. With this 99% confidence intervals, we can't say that because 8, right, our upper limit is more than 8. So that is really interesting. So as we increase the level of confidence, we widen the values for the parameter. And so as we decrease the level of confidence, we will then bring in the interval will become narrower. So try for a 90% confidence interval. What would our interval look like? It should be narrower. So it should be even narrower than this one, than the 95% confidence. So the higher the confidence level, the wider your interval. The lower the confidence level, the narrower your interval. Alright, now for the next example. In this one, sigma known. So now we know sigma, so that means we're going to go back to using z-scores. In this data, so this is the number of hours the athletes spend on athletic related activities, and you can find this data in StatCrunch. So if you go to StatCrunch, you should be able to find it there under athletic hours. So let me see if I can go to it. So if we go to my data, my groups, and go back to the groups here, we should be able to see athletic activity hours. And so if you open that up, you'll be able to see the number of hours here, and all we want from here is the mean. So go to summary stats, columns, number of hours, and we just want the mean and compute. And so this gives us the mean is 21.05 hours. So we don't need the standard deviation in this case because the population standard deviation is given to us in this problem. So we just need to make a note of the sample mean. So we can say that the sample mean was 21.05. I guess let's read the problem first. So a researcher is collecting data about a college athletic conference and its student athletes. A random sample of 40 student athletes is selected and their number of hours spent on required athletic activities for 1 week are recorded. Find a point estimate for the population mean, so that will be the sample mean, which is the mean number of hours spent on required athletic activities by all student athletes in the conference. And then we want to construct a 90% confidence interval for mu. Assume the population standard deviation is 2.3 hours. So this is the part that is important to see that, oh, we have the population standard deviation is 2.3 hours. So we can use that. And so this is what allows me to say, oh, I'm going to use a z-score because I know the population standard deviation. And so find x bar. So this data is in StatCrunch and we found it already to be 21.05. Find the required t value. So now, the required, critical value. Because now we know sigma, we're going to use the z-scores. So we're going to go over here to the z-scores and we're looking for a 90% confidence interval, right? Is that what it was? 90% confidence. So that means that, what do we need to do? So we need to select, so 90%, so our alpha is going to equal to 1 minus 0.90, which is 0.10, and then we need to do alpha over 2. So then our alpha over 2 is 0.05. So now we go to the z-score table and we're gonna go, as we did before, we look at the negative z-scores. So let's go back one page and we're looking for 0.05 which is usually it's already highlighted here. So that's we have 0.0505 and 0.0495. So is that star is when the area is 0.05, then negative 1.645. But remember, we're looking at our z, that will be the negative and then the positive. So we always take the positive one because our bell shape, right, is symmetric. Then we can, when we look at the critical values, so going back to the other picture where is z alpha over 2 and z alpha over 2, right? You have negative z alpha over 2 and positive z alpha over 2, but we just want the positive one. So it's easier to look up the 0.05 area, so negative 1.645, but essentially what I'm saying is ignore the negative, just take the 1.645. So our critical value then is 1.645. Now calculate the standard error. Let me bring you back to the notebook for a little bit to just kind of explain visually what I was saying, right? So when you have your percent confidence, so you have your z alpha over 2 is over here, that's the negative, and then you have the positive z alpha over 2. So when we're looking at a 90% confidence, so that means that you have in the two tails you have 0.10, so that's your alpha. So then alpha over 2 is 0.05. So when we look at the z-score table, the z-score table is telling us the stuff to the left, so it's giving us the negative z alpha over 2, so I just look up 0.05. But my critical value is really the positive, so I just want to look at z alpha over 2, but because of symmetry, right, I can look at the negative, and this value is just negative of that one, so I find that one and just drop the negative. So that's what I was trying to say. Okay, so calculate the standard error. So our error is the critical value, so z alpha over 2 times the standard deviation of the sampling distribution. And in this case, because we know sigma is going to be sigma over the square root of n. So we're going to have the 1.645, right, our critical value, times sigma, which was given to us to be 2.3 over the square root of 40, which is the size of the sample that was given to us. So when you do this on your calculator, we should get 0.598. So that is the error. So now we can construct the confidence interval, and so we can say, right, it's a sample statistic plus or minus the margin of error. So our lower limit is going to be x bar minus the error, and then you're going to have the population parameter, and then x bar plus the error. So we had found our average from StatCrunch to be 21.05, so minus the error 0.598, and then this is estimating our population parameter, so 21.05 plus the error. And putting that on our calculators, we get our lower limit then is 20.452, and the upper limit is 21.648. So we know then the average number of hours that student athletes spend on athletic activities is between 20.45 hours and 21.65 hours if you round to 2 decimal places, and this is with 90% confidence. So what if you did a 95% or a 99%? How will that change your interval? So try maybe a 95% on your own and see what you come up for this. So big ideas here are that when you know sigma, the population standard deviation, then you use the z-score tables as we did before for the proportion. And when you don't know sigma, that's when you use the t distribution. with degrees of freedom based on the sample size. Whatever your sample size is, subtract 1. Alright, contact me if you have any questions.